In the year 670 AD, a Byzantine naval fleet encountered an Arab naval force in the waters near Constantinople. What happened next was recorded by multiple witnesses and has never been fully explained. The Byzantine ships deployed a weapon. The Arab fleet caught fire. Not ordinary fire, fire that could not be extinguished by water, fire that burned on the surface of the sea itself, fire that witnesses described as liquid, as if the ocean itself had been set alight, pouring from tubes mounted on the Byzantine warships and consuming everything it touched. This weapon was called Greek fire, and for the next several centuries, it would protect the Byzantine Empire from naval invasion so effectively that historians credit it as one of the primary reasons Constantinople survived as long as it did. Then, the empire fell. The knowledge of how to produce Greek fire disappeared with it. We have never recovered it. This is not for lack of trying. For centuries, chemists, historians, military researchers, and scientists have attempted to reverse engineer Greek fire from the historical descriptions left behind. They have produced candidates, mixtures of quicklime, naphtha, pine resin, and various other compounds that burn aggressively and resist water to varying degrees. None of them fully match what witnesses described. None of them burn on the surface of the sea the way Greek fire apparently did. None of them have the specific properties that made Byzantine sailors so completely dominant in naval warfare for 300 years. The formula died with the empire. And the empire, it should be noted, kept it that way deliberately. Greek fire was a state secret so closely guarded that the emperor himself was said to be the only person with full knowledge of its composition. It was never written down completely. It was passed verbally in fragments to a small number of trusted people. When those people died in the collapse of Constantinople, the knowledge died with them. This is the second pattern, not just lost knowledge, but deliberately protected knowledge that became permanently inaccessible the moment the protecting institution ceased to exist. Think about what that means for everything we do not know.
There is a sword in a museum in Dresden, Germany. It was forged sometime between the 3rd century and the 17th century in a region of the Middle East, most likely in or around the city of Damascus in modern Syria. It is made from a steel so unusual that metallurgists still debate how it was produced. Damascus steel. You have heard the name. You probably imagine a very sharp, very beautiful blade. What you may not know is what makes Damascus steel physically different from any modern steel we produce today. Inside the blade, visible under high magnification, are carbon nanotubes, structures so small they were not even theorized by science until the 20th century, not observed until electron microscopes existed, and not intentionally manufactured by humans until the late 20th and early 21st centuries. Nanotubes that today require advanced laboratory conditions and precise chemical processes to produce. They are inside a sword forged by a blacksmith working with a hammer and a fire over 1,000 years ago. The specific steel used to produce Damascus blades, called Wootz steel, produced in India and traded across the ancient world, ran out sometime in the 18th century. When the supply of Wootz steel ended, so did the ability to produce Damascus blades. Blacksmiths attempted to replicate the material using different steel and different methods. They failed. The specific ore deposits, the specific impurities present in Wootz steel, the specific smelting conditions, whatever combination of factors produced those carbon nanotubes inside the blade, could not be reproduced without the original material. Modern materials scientists have spent decades trying. They have produced steel with some similar properties. They have not produced steel with carbon nanotubes formed through a pre-industrial forging process. They do not fully understand how a medieval blacksmith, working entirely by eye and intuition and inherited technique, was producing nanostructures that we associate with 21st century laboratory science. The knowledge existed. It was embedded in practice, in the hands and eyes of craftsmen who learned from craftsmen, who learned from craftsmen stretching back 1,000 years. And when the supply chain that fed that practice broke, the practice died, and the knowledge dissolved back into the unknown.
We are now 3 examples deep into a pattern that should be making you uncomfortable.
Roman concrete that self-mineralizes through a process we only understood in 2017. Greek fire that burned on water through a formula no one has recovered. Damascus steel containing nanostructures that no modern metallurgist has fully explained or replicated. In each case, the knowledge was real. In each case, it worked demonstrably, repeatedly, at scale. In each case, it disappeared. And in each case, our understanding of it remains incomplete. The standard explanation for this pattern is that ancient knowledge was fragile, that without printing presses, without institutions, without the infrastructure of modern science, knowledge lived in people and died with them, that we should not be surprised when it was lost, that loss is the natural state of pre-industrial knowledge. This explanation is partially true. It is also deeply convenient, because it allows us to maintain the story that says we are at the peak, that everything important that has ever been known is either still known or was simply not worth preserving, that the arrow of human knowledge points only forward. But the concrete does not point forward. The concrete points at a civilization that solved a problem we have not solved, using methods we do not fully understand, and then watched that solution disappear for 15 centuries while we built inferior seawalls that crumble into the ocean. That is not the story of progress. That is the story of something else entirely. In 1900, a sponge diver working off the Greek island of Antikythera discovered a shipwreck on the ocean floor. Among the objects recovered was a corroded lump of bronze that no one paid much attention to for decades. When researchers finally examined it properly in the 1950s, and then with advanced imaging technology in the 21st century, what they found inside that corroded lump was a device of such complexity that it permanently altered the academic understanding of ancient Greek technological capability. The Antikythera mechanism, a hand-cranked bronze computing device built around 100 BC, containing at least 30 interlocking bronze gears of extraordinary precision, capable of predicting solar eclipses, tracking the movements of the known planets, calculating the dates of Olympic Games, and modeling the irregular orbit of the Moon using a mathematical system so sophisticated that it was not rediscovered in Europe until the 14th century AD. A computer, built by hand, in bronze over 2,000 years ago, using a level of mechanical precision and astronomical mathematical understanding that the rest of the world would not reach again for 14 centuries. There is only one of them, one from the entire ancient world, from civilizations that spanned centuries and continents and traded across the known world. One single example of this device has survived. Not because it was the only one. The mechanism shows signs of repair and modification, suggesting it was used, maintained, and presumably manufactured alongside other similar devices, but because everything else was lost to time, to war, to the recycling of bronze for weapons, to the slow entropy of 2,000 years. We do not know who built it. We do not know what workshop produced it. We do not know how many existed. We do not know whether the knowledge required to build it survived the fall of the civilization that created it, or whether it died in some library fire in Alexandria or disappeared into the silence that follows the collapse of a complex society. What we know is this: someone built it. It worked, and then, for 1,400 years, no one on Earth built anything like it again. This is the question that the concrete and the fire and the steel and the mechanism are all pointing toward. Not whether ancient people were smarter than us. They were not smarter than us. The human brain has not meaningfully changed in the last 10,000 years. The question is not intelligence. The question is what happens to knowledge when the systems that carry it collapse. Every piece of knowledge we have discussed tonight lived inside a system. Roman concrete lived inside the Roman construction industry, in the suppliers who knew which volcanic ash to use, the engineers who knew the ratios, the harbor builders who understood why seawater exposure was an advantage rather than a threat. When Rome collapsed and those industries disbanded, the knowledge did not go anywhere dramatic. It did not burn in a single fire. It simply became unemployed. No one needed marine concrete in the same way anymore. No one was commissioning vast harbor works, and within a few generations, the specific operational knowledge, not the general idea, but the precise practice, was gone. Greek fire lived inside a state secret so tightly controlled that its disappearance was almost designed into the system. Damascus steel lived in a supply chain. The Antikythera mechanism lived in a workshop tradition. All of them were carried by systems, not by permanent institutions, not by books, not by anything durable enough to survive civilizational collapse. Now, ask yourself a different question. What is our knowledge living inside? The internet, you might say? Printed books? Academic institutions? Distributed systems too redundant to fail? And you would be right that these are more robust than anything the ancient world possessed, but robust is not permanent. And the ancient Romans, building harbor walls they intended to last forever, pouring a concrete that feeds on seawater and grows stronger with every passing century, were also building something they believed was permanent. They were not wrong about the concrete. They were wrong about everything around it.
There is a project currently underway at several universities, led in part by the UC Berkeley team that cracked the Roman concrete mystery, to synthesize a modern version of pozzolanic marine concrete using volcanic ash sources still available today. Early results are promising. The Tauber-Morite crystallization process can be replicated. A modern version of Roman marine concrete may, within the next decade, become a viable replacement for Portland cement in marine construction. More durable, lower carbon emissions, longer lasting, self-repairing. 2,000 years. That is how long it took us to circle back. 2,000 years of inferior seawalls. 2,000 years of crumbling harbors. 2,000 years of building things we knew would fall apart because we had lost the knowledge of how to build things that would not. And we did not lose it to some great catastrophe. We did not lose it in a single fire or a single war or a single deliberate act of destruction. We lost it the way most things are lost, quietly, gradually, one generation failing to pass something on to the next because the system that made it valuable had stopped existing, because the empire that needed harbor walls that lasted forever had fallen, because the people who knew had died, and the people who came after them had different problems to solve. This is the most unsettling thing about the concrete. Not that the Romans knew something we did not, not that we spent 15 centuries building worse things, but that the knowledge disappeared so completely, so silently, so without drama, that we did not even know it was gone. We thought we had progressed. We had not noticed what we left behind. So here is where that leaves us. We are standing at what we believe is the peak of human knowledge. And somewhere beneath us, in the sediment of everything that came before, there are Roman harbor walls still growing stronger on the floor of the Mediterranean. There is a bronze mechanism sitting in a museum in Athens that we spent decades not understanding. There is a sword in Dresden containing structures we associate with the most advanced material science of the 21st century. They are not anomalies, they are evidence. Evidence that the line between what is known and what is unknown is not fixed. That knowledge does not only accumulate, it also dissolves. That civilizations before us reached heights we are still measuring, still climbing back toward, still, in some cases, failing to match. The Romans did not think they were building something we would spend 2,000 years failing to understand. They were just building harbor walls. What are we building right now that the people who come after us will spend 2,000 years trying to figure out? And what are we losing right now, quietly, without drama, that they will never recover at all? That question does not have an answer tonight, but it should keep you up a little. Modern civilization has a story it tells itself. The story goes like this. Humanity began in ignorance. Slowly, painfully, over thousands of years, we figured things out. We invented science. We built institutions. We accumulated knowledge, generation by generation, until we arrived here, at the peak, the most advanced, most informed, most capable version of humanity that has ever existed. It is a comfortable story. It also has a problem. The problem is the concrete. In 2017, a team of researchers at the University of California, Berkeley and Lawrence Berkeley National Laboratory published findings that should have been front-page news in every country on Earth. They had spent years analyzing ancient Roman concrete pulled from harbor walls that had been sitting on the floor of the Mediterranean Sea for 2,000 years. What they expected to find was degradation, slow crumbling, the kind of decay that afflicts every material when left submerged in salt water for 20 centuries. What they actually found was the opposite. The concrete was not decaying, it was growing. Deep inside the volcanic ash matrix, a mineral called tobermorite was crystallizing, slowly, continuously, filling every microscopic fracture, bonding tighter with every passing decade. The seawater was not the enemy. The seawater was the engine. The concrete was feeding on the ocean itself and becoming stronger with every year that passed. The researchers were not prepared for this. Neither was the engineering world. Because here is what that discovery actually means. It means Roman engineers working 2,000 years ago, without laboratories, without electron microscopes, without any of the analytical tools we consider essential to materials science, had developed a concrete formula so sophisticated that it takes the most advanced research institutions on Earth 2 millennia and cutting-edge mineral analysis equipment to finally understand how it works. They did not stumble onto this. You do not accidentally produce a self-mineralizing marine concrete by randomly mixing things together. This required observation across generations. It required someone watching what happened to Roman harbor walls over decades, over centuries, and understanding that the material was behaving in a way no modern engineer would predict or even believe without seeing the data. They learned by watching time itself. And then, somewhere between the fall of Rome and the Industrial Revolution, we stopped watching. We moved on. We invented Portland cement in the 19th century and declared the problem of concrete solved. And compared to Roman marine concrete, Portland cement is a catastrophic step backwards. It absorbs seawater. It corrodes the steel rebar inside it. It begins micro-cracking within 50 years. The seawalls we build today will be rubble in a century. The Roman seawalls built are still standing on the ocean floor, intact, getting stronger every year, completely without maintenance, 2,000 years after the civilization that built them ceased to exist. We replaced the greatest building material ever discovered and called it progress. But here is the thing about the concrete. It is not the only example. Not even close.